All right. Attention up here, please. So I'm going to talk about the gold sheet I pass out to you first. This is probably a sheet in our next unit that you'll want out probably every day. But so I remind you of that, to be using that. But our next unit does directly tie into what we were doing. So I need your attention up here, please. We were multiplying polynomials before. That's what you just had your test on, multiplying polynomials. Now we are doing the reverse of that, which is called factoring. So that's why I gave you this math factor sheet. First of all, I want to ask this question. What is a factor, first of all? So you don't have to write this down, but like if I were to ask you, what are factors of the number 20? What would you say, Nadia? Okay, so 10 and 2 are factors of 20. Why are they factors of 20? Okay, guys, Michael and Andrew, did you hear what Nadia said? What'd she say? Exactly. You need to be listening, not just to me, to each other. So Nadia, why are they factors of 20? Okay, when you multiply them together, they equal 20. So what other numbers can multiply to 20? Besides somebody besides Nadia? They are on the sheet. Casey? 20 times 1. Andrew? 4 and 5. Are there any others? What? Did you say 2.4? That's 2 comma 4. Oh. Yes. So, when we talk about factoring, this is what I want you to understand. Factoring, this would be factoring the number 20. You might remember in earlier grades doing like prime factorization tree charts. But when you factor, what you are looking for is this would be two numbers. In our case, it's going to be two polynomials or two quantities that multiply to what's given. So it's the reverse of what you did before. Before, I was giving you what to multiply. You were just multiplying it and giving me the product. Now I'm giving you the product, and you're telling me what multiplies to that. But it's with polynomials. So where this chart comes in, where the gold chart comes in is it's to help you out. So in case when we're looking for factors of certain numbers, if you're not sure, you could find them on here. So this front side, what you're going to notice at the bottom, it says if a number is prime, it has a circle around it. Michael, look up here. If a number is prime, it has a circle around it. What does prime mean? Nadia?
For example, 22, it's 2 and 11 times each other, but for 13, it's not times by anything. It can't, because it's not times by a whole number. It has to probably have decimal, or you just can't equal it at all.
Okay. Yep. So yeah, all the prime numbers, notice nothing is written in those. There are still two numbers that would multiply to every prime number. Like what numbers would multiply to 2? 2 and 1. What numbers multiply to 3? 3 and 1. 5? 5 and 1. So a prime number means the only factors it has are 1 and itself. The only two numbers that multiply to those numbers are 1 and itself. So all of the circled numbers on here are prime, so you know their only factors are 1, like for 43, it's only 1 and 43, 1 times 43. All of the perfect squares have a square around them. What does it mean for a number to be a perfect square? Andrew? Kind of. Casey? Okay, so two numbers multiplied together, or rather one number times itself equals that number, like 9's a perfect square because 3 squared is 9. So you have 1 squared is 1, 2 squared is 4, 3 squared is 9. Those are your perfect squares. Also make note that all of these numbers, even though it's not written, so even for 4, you can still multiply 1 times 4 to get 4, even though it's not written in. It just has 2 and 2. But that's how you read this front chart. There is also a chart on the back that has the factors listed, but this is a list just of composite numbers. Composite is the opposite of prime, meaning it has more factors than 1 in itself. So it says if a number is missing, it's because it's a prime number and its only factors are 1 in itself. So 5 is a prime number, so you don't see 5 listed here. It starts right at 4. You don't have 1, 2, 3 because those are all just 1 times 1, 1 times 2, 1 times 3. And then again, in this list, like 4, the factor is 2, it's 2 times 2. You also do have the 1 times 4 is also 4. So the 1 times the number, those aren't listed on here. Just know that they're still factors. So keep that handy, and I'll probably just remind you to get this out every day just to have in front of you with whatever examples we're working on. So today, the first method of factoring that we're using is using the distributive property to factor. You have used the distributive property already to multiply. So I have here the multiplying, which is the forward version of the distributive property. Factoring is doing the reverse, the backward version. So if I were to multiply using the distributive property, so I have 5 times the quantity 2x plus 3, we know that we would distribute the 5, and you would get the answer of what is 5 times 2x? 10x. And then 5 times 3 is 15. So you'd get 10x plus 15. Okay, so now notice if I were to go backwards, so I'm giving you the 10x plus 15. I want to get this as my answer. That's your goal with factoring. You're going backwards. You're saying what two things multiply to equal that. So when you factor, what you are looking for is, or factoring using the distributive property, you're looking for the greatest common factor between the terms. So what is the greatest factor that they have in common? So if you want to make that note to yourself here, you look for the greatest common factor that's also known as the GCF. So if I say GCF, that's greatest common factor. And that's where you could be looking at your sheet. If you're not sure, you would look at the numbers 10 and 15 and find the factor, the biggest one they have in common. So that's where your sheet can be helpful. But what do 10 and 15 have in common? 5. Okay, so then you divide them both by 5, And this is how you write it. The greatest common factor, the 5, goes in front. And then in parentheses, you write what you get when you divide both terms by 5. So 10x divided by 5, I would divide the 10 and the 5. 10 divided by 5 is 2, so I'd have 2x. And then I have my plus sign, and then 15 divided by 5 is 3. That's how you go backwards with the distributive property. You find what is their GCF, you divide every term by it. The GCF goes in front of the parentheses, and then in parentheses is what you have left after you divide everything by it. Okay? Factoring. So I know I've just talked about factoring. It's the reverse of multiplying. You're looking for what two things multiply to equal what you're given. But formally, the definition is to express a polynomial as the product of monomials and polynomials. And what does product mean? What operation? Add, subtract, multiply, or divide? Multiply. Product is multiply. So in your answer, like notice what we just wrote here, this is 5 times the quantity 2x plus 3. Okay, so let's look at some other examples here. So if we look at example 1, it says factor using the distributive property. We have 18x and we have 24. What is the greatest common factor of 18 and 24? Andrew? 6. So GCF is 6. So then when I write my answer, I put 6 in front and then parentheses. I then divide these both by 6. What is 18x divided by 6? 3x plus 24 divided by 6 is 4. I do have my calculator sitting out here too today if you need to borrow a calculator for finding the GCF or the division. So then this is my answer. That is the factored form. Nathan, you don't need to be writing on the whiteboard. Nathan. You don't need to be writing on the whiteboard. Your focus should be up here. Nobody needs to be turned to look towards the back. Okay? When you factor, how could I check that this is right? Any ideas, Casey? I could distribute. I could do the reverse. So you can check your answers when you factor. So to check, that means I can distribute. So if I distribute the 6, I should get what I started with as my answer. So if I do 6 times 3x, that is 18x, and 6 times 4 is plus 24. If I distribute and I don't get what I started with, that means I factored it incorrectly. And that doesn't mean that you say, oh, I factored it wrong, I guess my answer is wrong and move on. Then look back and see, okay, how do I fix it? Okay, so let's look at number 2. I have 27x squared and I have 18x. Okay, so 27 and 18 have 9 as a factor, the greatest common factor. This one is a little different though because notice both terms do have an x. The first term has an x squared. The second term has just an x, which is x to the first. That means, also remember x squared is like x times x. That means both terms have one of their x's in common. So my GCF is actually going to be 9x. So we also have to look at variables instead of just the coefficients. So I have 9x, that would be in front of my parentheses. I divide these both by 9x. So what is 27 divided by 9? Okay, 27 divided by 9 is 3. And then if I have x squared and I divide by an x, what do I have left? I still have an x to the first power left. So remember, when you have it written this way, you can think of it as I had two x's, I'm getting rid of one, so I only have one left. Or remember to you subtract those exponents. 2 minus 1 would be 1. And then I have plus, what about 18 divided by 9? Is 2. And then if I have x divided by x, it's just 2. So here I had an x and I took it away. These, or I have 1 minus 1, which is 0. My x is canceled out. But again, you can distribute to check. So if you distributed and you did not get 27x squared plus 18x as your answer, then you know something is incorrect. Okay, so here's what I just talked about. To find the greatest common factor, or GCF, of variables, then you use the common variables to the lowest power. So in that example we just did, our common variable was x, the lowest power was 1. So we took out an x to the first. Okay, let's look at 3 and 4 here. Now, how many terms does number 3 have? There's 3 terms. So I have to look at all 3 of these. I would first look at the coefficients, look at the numbers in front. What do -4, well, and actually, if they're negative, I'm still just looking at 4, 8, and 2. What's the greatest common factor of 4, 8, and 2? 2. Okay, the highest number that goes into all of them is 2. Now I look at variables. Do all 3 terms have a common variable? Right, they all have an A. Not all of them have a B, because the first one doesn't have a B. The lowest power of A, here I have A squared, here it would be A to the first, and then this one is also A to the first. So the lowest power would just be A, or A to the first. So my GCF is 2A. So the 2A goes in front, and then in parentheses, I'm dividing all of these by 2A. So in that first term, -4A squared divided by 2A would be what? It'd be -2, and I still have A, because I have A squared over A to the first. I only took one of the A's away. I still have an A there. Then I'm going to bring down my minus sign. What is -8AB squared divided by 2A? So -4, so the -4. And then I do have the B to the second. The A's canceled out, but I still have B squared. And then I have plus 1B. Good. The 2's end up canceling to be 1. The A's cancel out, but I still have the B. So 1B, or if you just put B, you don't need the 1 in front, but the 1 there is fine. Okay, we'll just look at 4 together, and then we'll look at 5, and you'll have work time. So 4, how many terms do we have? 2? 15x and 25x squared. Okay, so 5 goes into both. Variable. I would also have an x. An x to the first power is the lowest. So 5x goes in front. Divide these both by 5x. What is 15x divided by 5x? It is just 3. Yep, the x's cancel out. And then 25x squared divided by 5x? That is 5x. Okay, questions? Okay, on the back. So this, make sure you actually write in, we'll talk about this together, but make sure you actually write this in because this is what we talked about at the very beginning, what makes something a factor. So it says, what are the factors of the number 12 and explain why these are considered factors of 12. So here, I'm going to start out this way. I'm going to answer the first part of the question. What are the factors of the number 12? So I'll say the factors of 12 are, what are factors of 12, Andrew? Do you mean dang, darn it? What? Exactly. Okay, the factors of 12 are 12, 1, 6, 2, 4, 3. Why? Why are those numbers factors of 12? Okay, so I will say they are factors of 12 because I'll say they multiply to equal 12. And then I'm going to put here, for example, 12 times 1 equals 12. And notice when I'm writing that, since it is a writing question, I'm writing the times and the equals in words, equals 12. Okay, but you could also go on to say 6 times 2 equals 12, 4 times 3 equals 12. So as long as you understand when you're factoring, you're looking for two things that multiply to equal what you're given. Okay, you're finding the factors, what multiplies to those.